Good morning. In last video, we have seen the value of FBD, and now we are interested with plastic section modulus. So refer again these two videos, 32, 33 in playlist of steel structures. Now this is our problem. Now we have value of FBD we got, that is 193.81. And then we have MU, that is 436.35. 436.35. Then we have now step 5, plastic section modulus. Plastic section modulus. Now in this, we have this channel section. Which we have to weld down I section. And already, if you remember, in structural analysis, we have this plastic section modulus. Now we are going to assume YP value somewhere here. Now YP, that is axis of plastic section modulus, or we can say plastic neutral axis, where it will act. So plastic neutral axis divides area into two equal parts. So now we will start with, so we are going to consider first, that is area, web area of channel. So we have, this is our channel. So this area we are going to consider. So we have channel IMC 300. So we have this area 300 into 7.6 plus. Then we have second area, that is of this part, which is flange of channel. We have thickness of channel flange is 13.6 into, we have YP minus thickness of web 7.6. Then we have plus, that is area of flange of beam. So we are going to consider this area. I am using separate colors so that you can understand very clearly. So plus we have 250 into 14.7 plus, then we have last area, which is area of this web of beam. So this value. So this we have, total we have YP. From YP we have to subtract thickness of web of channel 7.6 minus we have to subtract thickness of flange of beam 14.7. And therefore we have thickness of web, we have 9.9 multiplied by YP minus 7.6 minus 14.7. And this is equal to total area upon 2, which is 16686 upon 2. Now I have calculated the values. We have area which is independent of YP. So these two areas, we have 5955, and then areas, this minus, and then we have to multiply these minus, and these areas we have 324.13, so this will be minus 324.13 plus this 13.6 yp plus 9.9 yp, so we have this as 23.5 yp, that is equal to 8343, and I got this value of yp as 115.41 millimeters. Then we will find zp, you can write compression or you can write top, and now for this again I will draw a separate diagram, because this is most important if we will talk about uh, gantry girder. So these calculations plays very important role, and if your calculation goes wrong, then this everything will be wrong over here. So now we have this will be beam, and then we will go. Now we have YP below this because we have depth of flange as 90. So we have this value now 115.41. Now we will start with, we have first channel 300 into 7.6 into, now we have to be from center, so this distance. So we have to subtract this half thickness of web of channel. So 115.41 minus 7.6 upon 2. This will be of first part, that is of this channel, web portion. Now we will go second, that is flange portion. So we have this one. So total 90 we have. So we have this portion plus 13.6 into 90 minus 7.6 into distance from center of this. So we have this will be 115.41. We have 115.41 minus 7.6. We have first this value, and then we have minus 82.4 by 2. See, first we have to subtract this. We have to go from center of this to this distance. So we have to subtract this half part, which is 82.4, and then this 7.6 we have to subtract total part. Then we have next part, that is of flange of beam. So we have this portion now, and then we have plus flange, we have 250 into 14.7 into, now we have 115.41. We have to subtract, that is value of 7.6, and then from center of this, so we have 14.7 by 2. So from center of this distance, so 7.6 and half of this flange thickness. And then we have last part, that is of web. So this portion now, and we have plus 9.9, that is thickness of this, multiply by, we have 115.41, and subtract first web thickness of channel, which is 7.6, then subtract flange thickness 14.7, and then we have square of this upon 2, and then we will get these values. Now I will have separate values, I will mark over here so that you can calculate, you can check your answer and my answer also. 254.48 into 10 raised to 3 plus 74.65 into 10 raised to 3 plus 369.19 into 10 raised to 3 plus 42.91 into 10 raised to 3, and total we have 741.23 into 10 raised to 3 millimeter cube. And then bottom we have to find out. So I will just show you over here only. So we have first part this flange. So now we will have this distance. This distance will be total we have 50507.6. So 507.6 minus 115.41. And we have this value 392.19. So we have this value. So now we have from center of this will be first value. And then we have second will be this depth, which will be 392.19 minus thickness of flange. So that we will go in next part. So I will write ZP tension, or you can write ZP bottom. So equal to first flange, we have 250 into 14.7. Already I shown you. And then we have this value 392.19. We have to subtract from this half of thickness of flange. Plus, we have second part, remaining part of web, which will be 9.9. And we have this value 392.19 minus 14.7. And then we have square by 2. And then I will write this value separately again. 1414.29 into 10 raised to 3 plus 705.37 into 10 raised to 3, and we have this value 2119.6 into 66 into 10 raised to 3 millimeter cube. And then we have next step, that is step 6, design bending strength. So we have design bending strength. And then we have this design bending strength, that is MD, which is beta B, ZP into FBD. So beta B we will have 1 again. I will not go for this plastic or compact or likewise. So FBD value we have already mentioned 193.81. Sorry, first we have ZP. So ZP we have total value, that is 2860.89 into 10 raised to 3 into 193.81. Now ZP we have ZPC plus ZPT. ZPC we have we have this value 741.23 plus 2119.66, and that is into 10 raised to 3, and that value we got 2860.89 into 10 raised to 3 millimeter cube. And this value comes 554.47 into 10 raised to 6 Newton millimeter. This is 554.47 kilonewton meter greater than 436.35 kilonewton meter. So likewise, we have to solve it. So this is greater than the bending moment. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.